Today, we're implementing Retrieval Augmented Generation, the solution that helps AI actually understand your business data. I will show you the exact patterns that companies are paying developers to apply. It's one of the most in-demand skills for engineers right now, regardless of your tech stack. We are diving deep into how to implement the core of RAG, intelligent retrieval and context-aware generation. We will be using Spring AI, but the principles that you learn here are universal and will make you a more valuable developer. Stay tuned. In the last video, we built a document ingestion and vector search, the data layer that every RAG system needs. If you missed that foundational piece, pause this, watch it, and then come back. The link is below. Today, we're building on top of that. We are moving beyond just storing data to intelligently retrieving it and generating domain-specific answers. We established that raw LLMs hallucinate. RAG solves this by grounding AI responses in your actual data. We talked about vector databases. They store meaning, not just keywords, which is critical for semantic search. We walked through the ETL pipeline, data extraction, chunking, loading data into Pinecone, and then seamlessly switching to MongoDB Atlas without changing the core logic, thanks to Spring AI's abstractions. RAG isn't one technique, it's a spectrum of implementation strategies. Each one solves different complexity levels and use cases. Let's switch to IntelliJ IDE, where we will review the code and see how Spring AI helps us build the retrieval and generation parts of RAG. We will start with the simplest interaction and progressively build up to more sophisticated techniques. Each step will show you a different approach to RAG and highlight its trade-offs. First, we will look at the most basic way to talk to an LLM using Spring AI Chat Client. This code is simple. We get a Chat Client instance, use its prompt method to send a literal string, and then call to execute the request to the LLM. And finally, content method to grab the text response. Now, let's think of this approach. Direct LLM interaction. No vector store, no RAG, no document retrieval, no external context. The model responds based on its training data. It's fast and simple, but limited to general knowledge. On one side, it's really easy and a great way to quickly test if your chat client and LLM integration are working. On the other side, this offers zero context from our own documents. If we ask the LLM about specific data from our project or company, it will either say that it doesn't know or hallucinate in an answer. There is no grounding in our specific knowledge base. This is fine for general chat, but not useful for building domain-specific AI. So if we want the LLM to answer based on our documents and to follow specific instructions on how to answer, we need more control over the input we send it. To gain more control and start actually implementing RAG, we need to structure our prompts and bring in our vector store. Here is how we can use a prompt template together with Spring AI's Question-Answer Advisor. In this method, you see two key things. First, we define a prompt template. This template has placeholders like query for the user's question and question-answer context. This latter placeholder is where the question-answer advisor will automatically inject the documents it retrieves from our vector store. We also used specific rules for the LLM within this template, guiding its response style. Second, we create an instance of Question Answer Advisor. We pass our vector store to its builder and our custom prompt template. We then use chat client prompt with a question with the advisor. The advisor intercepts this. It performs a similarity search in the vector store for the documents related to the question and populates our custom prompt template with both the question and the retrieved context, and then sends this final augmented prompt to the LLM. This approach combines structured prompting with automated retrieval and answer generation. The prompt template gives us the much needed control over the LLM's input and allows us to embed specific instructions. It leads to more consistent and controlled responses. The question answer advisor then simplifies the RAG loop by automating the retrieval of context from the vector store and the application of the template. This is a quick way to get a basic RAG system up and running for standard Q&A. You may be thinking, what is an advisor in Spring AI? Spring AI advisors are components that encapsulate common AI patterns into reusable building blocks. Instead of manually orchestrating document retrieval, context injection, and prompt engineering every time that you build RAG system, advisors handle these repetitive patterns automatically. Think of them as middleware for your AI applications. They are in between your business logic and the underlying AI infrastructure, and they manage the complexity of retrieval and generation pipelines. This advisor pattern means that you can focus on your application logic instead of rebuilding RAG infrastructure from scratch every time. Let's stick with the question answer advisor for a moment, but focus on how we can customize the documents it retrieves. This is done using a search request. This code is very similar to the last one, still using question answer advisor. The key difference here is the search request call when building the advisor. We're providing a search request object where we've specified a similarity threshold, meaning that documents must have at least and 0.8, in our case, similarity score to be considered, and top K with a 6 parameter, asking for the top 6 most relevant documents. The advisor will use these parameters for its internal query to the vector store. Question Answer Advisor is great for straightforward document-based Q&A, documentation chatbots, internal FAQ systems, customer support for well-defined knowledge bases. The retrieval patterns are predictable. Now let's talk about the limitations. Question Answer Advisor is convenient, but might feel like a bit of a black box if your retrieval needs to become more complex than what it offers out of the box through the basic search request tuning. When you need to perform multi-step retrieval or apply sophisticated re-ranking to the retrieved documents before they hit the prompt, or if you need to integrate hybrid search, this advisor alone might not provide enough flexibility. It's excellent for its intended purpose and a straightforward Q&A, but it has its limits for highly customized RAG pipelines. The Retrieval Augmentation Advisor in Spring AI offers a more powerful way to integrate document retrieval into your chat client calls. In this code, we're building a Retrieval Augmentation Advisor. The most important part here is the document retriever configuration. We are equipping the advisor with a vector store document retriever that's set up to query our vector store with a specific similarity search threshold. When this advisor is used in the chat client prompt chain, it will automatically execute its document retriever based on the user's question. The documents found are then injected into the prompt context, making them available for the LLM. Here we can also add different modules like the document joiner, query augmenter, query transformer, and other. Now, let's really dig into what makes this advisor special. The core strengths of Retrieval Augmentation Advisor is that it's highly modular by design. You can think of it as a plug-and-play system for data retrieval within your RAG pipeline. You can configure it with any implementation of Spring AI's document retriever interface. It means that you can seamlessly swap out different retrieval strategies or data sources without redoing your core RAG logic. For example, today you might use the vector store document retriever to get the data from your PG vector or Pinecone database. Tomorrow, if you need to pull documents from a traditional content management system or another data source, you could implement and plug in a custom content management system document retriever, and the Retrieval Augmentation Advisor would integrate it just as smoothly. This design effectively decouples the data retrieval logic from the AI model interaction. The advisor's job is to get the documents. How the LLM uses them is a separate concern. This enables truly flexible RAG implementations where various data sources and retrieval mechanisms can be easily swapped or combined. You're not locked into one way of fetching data. Because it's so modular and focused, it serves as an excellent building block if you need to construct a more complex RAG workflow where document retrieval is just one distinct, interchangeable step. When used with a typical document retriever for a single user query, it performs one pass at retrieval. For truly difficult user questions where the initial query might be ambiguous or multifaceted, even the most flexible single pass retrievals might not be enough. The single pass is not sufficient for highly difficult user questions where the initial phrasing doesn't capture all the nuances of the information that they need. To improve our chances of finding all relevant information, we need to explore techniques that go beyond a single query, like a multi-query expansion. It uses Spring AI's multi-query expander to generate multiple versions of the user's question, and then retrieves documents for all of them and synthesizes this comprehensive context for the LLM. This is a more involved multi-step pipeline. This multi-query expander method demonstrates a more complete, even though more manually orchestrated pipeline. So let's break it down. First, we expand the query. We take an original complex question and use the multi-query expander. This component itself uses an LLM to generate several variations of the original question. Here, we ask for 4 variations. Second, we retrieve documents for each expanded query. We set up a document retriever. In this case, it's a vector store document retriever to hit our vector store. Then, we loop through each of the expanded queries from step 1. For each variation, we call document retriever retrieve and collect all these documents, performing some basic deduplication. There is also fallback logic if no documents are found. Then we construct a synthesized context and a final prompt. We take all the unique documents retrieved from the query variations and concatenate their content into a single synthesized content string. We then define a new prompt template, our synthesis prompt template specifically designed to instruct the LLM on how to answer the original query using its rich context. Then we call the chat client for the final answer generation and send this comprehensive final prompt. This approach shows enhancing retrieval recall by generating multiple queries and then performing retrieval for each, and finally synthesizing the results before prompting the LLM. This improves the chances of finding all relevant documents, especially for difficult user questions. This usually leads to higher quality, more complete answers. This is the most complex of the methods so far. It introduces additional LLM calls for the query expansion step, which can add to the latency and cost. The manual orchestration for retrieving multiple queries, aggregating results, and potentially handling deduplication adds to the implementation effort. So it's an extremely powerful way, but it requires careful design of the overall pipeline to manage these additional steps. Now, let's see how each of these patterns that we've implemented perform when we run the code. Let's start with a simple question-answer advisor. We launch it with a simple question that it should be able to answer as our documents contain the documentation of different agent frameworks. For example, here we're asking, what is Pydantic AI? When we run the code, it does a good job at answering our question. When we run the Retrieval Augmented Advisor for this question, it also gives us a good result despite having a different format. As you can see, it's a one-liner, but answers our question pretty well still. Now, if we ask a more challenging question, like which framework works with Java, or something else that doesn't specifically provide a clear-cut answer, we will start seeing degrading quality of answers. The really interesting execution to check is with multi-query expansion, where queries can be decomposed into multiple queries, which can help with the quality of output. Here, our question was, which framework works best with Gemini? There is no direct reference to what the best framework for this is, because most of them can work with it, even though it's not explicitly mentioned. Agent Development Kit docs have a mention of Gemini, so we'll see if this is going to affect the answer. As you can see, the query expander created 4 more similar questions to cross-check with our data. Then it sent and synthesized the context and the original query to the LLM and gave us an answer that is more elaborate than I don't have enough information. You've seen the spectrum of RAG tools and patterns demonstrated with Spring AI, but relevant far beyond just that. Remember that RAG is a pattern, not just one tool. Whether it's Spring AI, LangChain, or something else, the core concepts of retrieval, context augmentation, and guided generation are the same. Spring AI provides different levels of abstractions to implement these patterns, from highly automated advisors to foundational components that you can weave into custom pipelines. Prompt engineering is also universal. Effective prompt template design is important in any RAG system. Clearly instructing the LLM on how to behave and how to use the provided context is a non-negotiable thing for quality results. I always recommend to start simple and scale up because it often makes sense to begin with the basic Q&A flows. As your use case demands more, you can then add complexity like the custom document retriever logic or other techniques like the multi-query expansion. The better and more comprehensive the context that you retrieve, the better the answer that your LLM generates. Also remember the scaling tips. Monitor your document chunks, test with different file types, version your data, batch large ingestions, and handle failures gracefully. These principles still apply because good data means good answers out, no matter which RAG framework or technique you're using. Now you have the practical knowledge to build AI that doesn't just chat, but understands and leverages your specific data. This is the skill that companies are paying top money for and translates across the AI development landscape. Make sure to like this video and subscribe to my channel. Thanks for watching. I'll see you in the next video.
Your reality has changed.
You're stuck in your career. You're either using AI or being used. Do you still believe success is guaranteed? You feel it's time to wake up. Old strategies don't work anymore. Welcome to the real world. It will never be the same again. You need to fight for your future. Learn to spot truth from lies. I will help you. Together, we will win.